Hello everyone, let me ask you a simple question. If I will roll a dice n number of time and can be very large, then what is the average outcomes we are going to achieve? Will it be maximum number or minimum number or some number lying between 2 and 5? Your answer will be long run average, and long run average is what expectation of a random variable say. Let's go deep dive into the mathematical form of expectation of a random variable. Before going into the mathematical form of random variable, let me introduce you about two basic concepts. One is the type of random variable. There are two types of random variable. One is discrete random variable and another is continuous random variable. And another concept is the underlying probability distribution function. For discrete random variable, the underlying probability distribution function is probability mass function. And for continuous random variable, underlying probability distribution function is PDF, probability density function, which we denote by f of x, and for probability mass function we denote by p subscript x. Now for discrete random variable, let's say that x can take value x1, x2 to xn and its associated probability p1, p2, p3, pn. These p1 to pn is PMF because this is discrete random variable. Then expectation will be summation of x1 times p1 plus x2 times p2, so on. And in short, we can write summation of xi times p of I. For continuous random variable, let's say that y take value between a and b, and a general like f of y is the PDF of this random variable y. Then expectation of y will be integration of y times PDF times dy from a to b. This will be the expectation of a continuous random variable. So in short, we can say that expectation of x is equals to x times p of x summation of x times p of x when x is discrete random variable, and integration of x times f of x dx when x is continuous random variable. Now let's understand the same thing by an example. Let's say x is a score run by Virat Kohli. It will be discrete random variable, right? Because it will take a discrete value. For an hypothetical scenario, consider he played 365 match and in each match he scored 1, 2, 3, 4 runs respectively till 365. Then what will be the expectation of the x? The expected value of x is equal to summation of xi p of xi. Xi is 1, 2, 3, 4, and the probability of each outcome of x, which is 1, 2, 3, 4, is 1 by 365. Why? Let's take example of 4. What is the probability of getting x as a 4? It is the number of occurrence of 4 divided by total number of occurrence of x. So it is 1 by 365, right? Because 4 comes only once in these 365 days. If you add up these by simple algebraic calculation, you will get 183 is the average score run by Virat Kohli. Similarly, let's take an example of continuous random variable. Consider a scenario of temperature at a place in summer, and in summer the temperature vary from 5 degrees centigrade to 25 degrees centigrade, or any season, not necessarily summer, you can take rainy season or something. And the PDF of this temperature following quadratic, which is equals to f of t is equals to t square. Then the expectation of t is integration of t times f of t dt, and this f of t is this PDF. So if you integrate from 5 to 25, you will get some number like this, and this is the expectation value of the continuous random variable t. Before ending this video, let me give you a question for you. Let's say x1 and x2 are two continuous random variable and a and b are two constant number. Expected value of x1, let's say, is k1 and k2. k1, k2 are constant. Then what will be the expectation of ax1 plus bx2? If you know the answer, comment below. I will check it out. Thank you.